Welcome back. We're diving right back into our exploration of, well, everything, using Anubhav Srivastava's Nothing, Everything as our guide to the very fabric of reality.
Yeah, last time we sort of laid the groundwork, didn't we? We touched on the wave function, superposition, even entanglement, basic quantum weirdness.
Exactly. Necessary weirdness. Because today, we're tackling the big interpretations. Quantum math works, we know that, but what does it mean for reality? That's the mission.
Right. And there are two main camps, philosophically speaking, that try to answer that.
Okay, so let's kick things off with the classic, the old guard, the Copenhagen Interpretation.
Copenhagen view, yeah.
Yeah.
Developed mainly by Niels Bohr back in the 1920s, the core idea is pretty straightforward, at least on the surface.
Which is?
That quantum systems, they exist in this kind of fuzzy state, a mix of all possibilities that superposition until something observes them.
Okay, the act of observation or measurement. That's the trigger.
Exactly. And poof, the wave function collapses. All those possibilities just vanish except one, the one we measure.
And that's the key point for Copenhagen, right? That the act of observing is what makes reality concrete. It picks one outcome.
It does. And look, empirically, it works incredibly well. It's been the standard for decades. But philosophically, it's got some holes.
Like what? What's the main criticism?
Well, the big one is it never really explains how or why the collapse happens. What counts as an observer? Does it need consciousness?
Or just a detector?
Right. It could be a Geiger counter.
Yeah.
But the interpretation itself kind of needs this external disruption, this measurement to make things real. And it doesn't explain the mechanism behind that disruption. It leaves things fundamentally probabilistic and, well, fuzzy until measured.
That lack of a clear mechanism, that sort of randomness, that definitely feels unsatisfying, which I guess leads us directly to the alternative.
It does. Enter Hugh Everett III in 1957 with a really radical proposal, the many worlds interpretation, MWI.
Okay, many worlds. What's the core difference here?
The biggest difference, no collapse. Everett said the wave function never collapses. It just keeps evolving according to the math.
But then, what happens when you measure something? If it doesn't collapse, how do we get a single result?
Well, according to MWI, you don't just get a single result. When a measurement happens, or any interaction that could lead to different outcomes, the universe itself splits.
Splits?
Yeah, it branches. Every single possible outcome of that measurement becomes real, just, in its own separate parallel universe. These universes don't interact with each other after the split.
Whoa. Okay, so instead of collapsing possibilities, reality just expands to accommodate all of them.
That's the idea. It sounds extravagant, I know. Infinite universes springing into existence all the time.
That's the main pushback, isn't it? It seems incredibly wasteful, maybe even untestable, because we can't access those other worlds.
Absolutely. That's the biggest hurdle. It's not easily falsifiable. But look at the upsides for a theorist. First, it's deterministic. The underlying math just flows smoothly. No sudden random jumps. Every possibility happens. Guaranteed.
Okay, so it removes the randomness problem of Copenhagen.
Exactly. And it removes the special status of the observer, too. The observer, the measurement device, you're all just part of the quantum system that splits along with everything else. No need for an external collapser.
Right, I see the elegance. It avoids the tricky philosophical questions of Copenhagen, but at the cost of, well, infinite realities.
A hefty price, some would say. But this is where it gets really interesting for our deep dive into Srivastava's Nothing, Everything.
Because MWI lines up with his theory.
It lines up remarkably well, almost perfectly actually. That core MWI concept, no collapse, all possibilities realized in parallel branches, is absolutely foundational to the idea of timeless concurrence presented in the book.
Okay, unpack that. Timeless concurrence.
If the wave function never collapses, if all these branches just are, then it suggests all these possibilities aren't just potential futures. They are all existing eternally side by side right now. The universe isn't a single story unfolding. It's the entire library of all possible stories existing simultaneously.
So the deterministic nature of MWI, the fact that everything must happen somewhere in the multiverse, that's the engine driving the philosophical structure in Nothing, Everything.
Precisely. It suggests reality is this vast static ocean containing every possibility, not just the single stream we perceive. It takes the mathematical implications of quantum mechanics, specifically MWI, to their ultimate philosophical conclusion.
It's quite a mind-bending shift in perspective. Both interpretations use the same successful math.
Yep, same equations, predicting the same experimental outcomes within our branch.
But MWI By ditching the collapse and embracing the infinite, it basically opens the door for the kind of comprehensive theory of reality Srivastava is proposing in Nothing, Everything.
That's the connection. It suggests the reality we experience is just one facet of a much larger, potentially infinite and unchanging whole.
Okay, that leaves us, and you listening, with something pretty profound to chew on. If many worlds is closer to the truth, if every choice you didn't make actually played out in another branch of reality,
If every possibility is realized somewhere,
then what does that really mean for our sense of free will versus determinism? If it's all happening anyway, where does choice fit in? Something to think about as we gear up for the next part of this exploration.